I am coming after 2 3 days of gap. Right, there was an Onam celebration. That's why I thought that I should take some leave of you. That I did. Right, relaxed and celebrated the festival. Right. I am coming with a new lesson today. What is called electromagnetic waves. Let us finish this lesson also. All the tension will be over. Then very little number of lessons will be there. Very little means in the month, by 15th of this month, everything can be finished. The total portion can be finished. That is my word promised to you. If you want, I can finish within 15 20 days everything. If you don't want, I can lengthen it. I can prolong it. That is according to your uh, will and wish, right? So you have to time give me the feedbacks of these classes, what we are doing. That will strengthen my spirit also. That most of the time my students are not doing. Right? Please do that also, right? We have to go with the practicals also. Practicals means I have to go to school and camera and everything will be set there and perform the practicals by myself and to give you the what is called the readings. You will see how the practicals, every practical is done. That is what my plan is. A film is shot there and that will be sent to you. Link will be sent to you and you will see every practical. I think about up to 10 practicals we had to do this year, right? So, okay, let that be there. So, this is electromagnetic waves. Electromagnetic waves means there are so many electromagnetic waves we have come across. Even class 10th also we have come across so many electromagnetic. That means about 7 electromagnetic radiations are there. Electromagnetic radiations are also called as electromagnetic waves. Just like gamma rays, X-rays, infrared, ultraviolet, radio waves, microwaves, visible radiations, etc., etc. Right? About 7 electromagnetic radiations are found so far. Electromagnetic radiations were actually discovered by Maxwell. Right? Maxwell, a scientist called Clerk Maxwell, discovered the waves, radiations, and he had made expressions also for that. That expressions are called Maxwell's equations, right? Okay. So we have seen Faraday's laws of electromagnetic induction. In Faraday's laws of electromagnetic induction, we have seen a time-varying magnetic field can produce electric field. That itself is changing with the time. We are changing actually a change in magnetic flux linked to the coil. And due to that, an EMF is induced in the coil. EMF induced means electric field variations are taking place in the coil. So time varying magnetic field can create a time varying electric field. Time varying electric field means the magnitude and the direction of the electric field vector varies with the time. So if we can produce a time varying magnetic field, means a magnetic field whose magnitude and direction change with the time, if we can produce in the space, that will produce the other field, what is called electric field, that also time varying. So both these can be said to be changing with the time, just like a sine function. Accordingly, as the sine function, just like current and EMF and the AC current varies, same is the case here also. That case it is current and EMF. In this case, it is electric field and magnetic field when changes sinusoidally. Sinusoidal variation is the basic variation of electric field and EMF and current, as we have said in the last topic, AC. In this case, the time varying electric field is sinusoidal variation of electric field when created in a space or produced in a space. A time varying magnetic field automatically created there. So these two time varying electric and magnetic fields are interacting with each other. One when produced, other must automatically produced, must be produced. So this is actually what is happening. Either the electric field is produced. If the electric field, the time varying electric field is produced, with that a time varying magnetic field also produced. If you can produce a time varying magnetic field, and with that and time varying electric field also will be produced. So once one time varying field is produced, the other will be produced automatically. So these two fields, when that takes place or produces in a space, the result of that, the result of these two interacting field is electromagnetic waves. You know that how time varying electric field is produced. Time varying electric field is produced due to oscillation of charges. Just in the last topic, we have studied the LC oscillations. In LC oscillations, charge first in one half cycle, charge is flowing from one plate of a capacitor to the other one. The next half cycle, it is flowing from other plate to the second plate to the first. First condition, first plate to second plate, the positive charge is flowing. And the next half cycle, second plate to first plate, the positive charge is flowing. This is an oscillation. Oscillating charges can produce time varying electric field. Time varying electric field is the reason for production of time varying magnetic field. Both when takes place together in a region in the region of a space, then there occurs electromagnetic waves, right? So in this case, one thing you have to understand is that suppose that the magnetic field is in the Z direction. Z direction means you just stand at a table, right? At the corner of a table. Let us suppose this is the I am saying that table is not actually showing in the camera, right? So the right hand shows that of the x-axis, and the left hand shows that of the y-axis. X-axis is one side of the table, and y-axis is other side of the table. And at the corner, if you erect a vertical line, a stick and etc., that is the z-axis, right? So suppose the electric field is vibrating in the z-axis direction, right? Z-axis direction, and the magnetic field is in the y-axis direction. One is in the z-axis direction, right? Other is in the y-axis direction. So these two fields are sinusoidally varying in two planes. One is in the xz plane and other is in the xy plane. XY plane and XZ plane both are perpendicular to each other, right? If you produce the magnetic field in the XZ plane and against that, the electric field produced will be in the XY plane, or vice versa. If we can produce the electric field in the XY plane, the magnetic field will be in the XZ plane. So in this case, what we are taking is that this is what is called E is in the Z plane. XZ plane, the variation of electric field is in the XZ plane. Then the variation of magnetic field is in the XY plane. Remember, these two fields are acting in two mutually perpendicular planes. They can never be in the same plane. This is the most important basic idea you have to keep in the mind. Whenever anywhere in the space, if we can produce a what is called a time varying electric field or magnetic field, both cannot be in the same plane, but they will act in the two mutually perpendicular planes. So this is the most important thing you have to keep in the mind. So one may be in the XZ plane, other may be in the XY plane, right? But the result of that, what do you call it as electromagnetic wave, that travels along the x-axis. X-axis is perpendicular to both the z-axis and also y-axis. So magnetic field is in the z-axis, right? And electric field is in the y-axis. And the direction of propagation is in the x-axis. Therefore, the direction of propagation of the electromagnetic wave is perpendicular to both electric and magnetic fields. That is why it is called a transverse wave. Electromagnetic wave is a transverse waves, right, in nature. So these are the two relations we can say. EMF E is equal to. So this relation also can tell you something about how the electric and magnetic fields are produced. This is Faraday's law. According to Faraday's law, the EMF produced, according to Faraday's law, the EMF produced in a coil is EMF is directly proportional to rate of change of magnetic flux. Magnetic flux means magnetic field variation. When magnetic flux variation takes place, magnetic field variation is taking place. Field variation is what is called flux variation. That means magnetic field produces EMF. EMF is given by the relation a line integral to the electric field. We have seen that potential difference in the first topic, electrostatics. We have studied that voltage or potential difference is defined as line integral of the electric field. That means E dot dl. So electric field is equal to magnetic field. That is, change in magnetic field can produce electric field. In the same way, another expression is this is called Maxwell's equation, Clark Maxwell's equation. Clark Maxwell and scientists who modified ambient circuit law. Ambient circuit law, everybody knows that. According to ambient circuit law, the line index to the magnetic field over a closed magnetic path is equal to mu zero times the current enclosed by the magnetic path. Right? I don't need to repeat it because many times I did it when I taught you ambient circuit law. Right? Okay. This is the relation Maxwell's Maxwell's equation is called. That is B dot dl, line into the magnetic field. This is modified form of ambient circuit law. Ambient circuit law mathematically we wrote as कैसे लिखे थे हम लोग B dot dl is mu zero I we wrote. Maxwell modified it. This is the correct way of representing ambient circuit law. Ambient circuit law, some ambiguity was there, confusion was there. That confusion was removed by Maxwell. And he changed the equation in this form. Ambient circuit, the basic equation was D dot dl is equal to mu zero I. But changed one by Maxwell is mu zero into epsilon into d phi E by dt. D phi E by dt. That means change in electric field is equal to change in magnetic field. So electric field when changes, there will change time varying electric field can give rise to time varying magnetic field. And also time varying magnetic field can produce time varying electric field. These are the basic relations, which is the base of understanding electromagnetic waves, right? So in electromagnetic waves, two fields are taking place in the space simultaneously. Due to the interacting fields, a wave disturbance is created in the space, and that wave disturbance is called electromagnetic waves, right? So this diagram is very important, very easy to understand, right? Yeah, electric field is in the Z direction and the other is in the Y direction, and the wave is traveling in the X-axis direction, right? Okay, one is in the XZ plane, one variation is in the XZ plane, this is XZ plane, other is in the XY plane, and the wave is traveling in the X-axis direction. X-axis direction is perpendicular to XZ and also XY. That is why this wave is called a transverse wave, right? Speed of a transverse wave is given by, is also a very important relation. Speed of a transverse wave is given by, in the space, suppose that the light is also an electromagnetic wave only, visible radiation is electromagnetic wave. Speed of an electromagnetic wave is represented by C is equal to. C is equal is also very interesting to see. That is C is equal to 1 by root of mu zero epsilon zero. C is equal to 1 by root of mu zero epsilon zero. Mu zero magnetic permeability and epsilon zero electric permittivity. So the velocity of light is also depending on the two physical quantities related. One is magnetic and other is electric. When you calculate the value, put the value of this mu zero and epsilon zero, we will get the value is equal to 3 into 10 raised to 8. So this value, for the first time found by Maxwell, the velocity of all electromagnetic waves is found to be equal to 3 into 10 raised to 8 meter per second. So this we can put the value is 1 by root of mu zero. Mu zero means 4 pi into 10 raised to minus 7. Because mu zero by 4 pi, right? Mu zero is equal to mu zero by 4 pi is equal to 10 raised to minus 7. mu 0 by 4 pi in magnetism is equal to 10 raised to minus 1. Therefore, mu 0 is equal to 4 pi into 10 raised to minus 7. Right? This is Henry per meter. Henry per meter. And the epsilon 0 is equal to 8.85 into 10 raised to minus 12. This is Faraday per meter. So this relations also known as Henry per meter and other is Faraday per meter, right? Other unit also there. That time I said another unit, but this is another short form, right? Mu 0, the unit of mu 0 is Henry per meter and epsilon 0 is Faraday per meter. The value, this is also put here. That means 8.85 into 10 raised to minus 12. You will get exactly this value is equal to 3 into 10 raised to 8 meter per second. So this is a very great surprise. So we have seen that the velocity of light is represented in terms of magnetic and electric nature. That is depending on magnetic and electric nature. Magnetic nature because mu 0 is appearing. Electric nature because epsilon 0 is appearing. Right. So this is also a very wonderful thing. All electromagnetic radiations, irrespective of the method of preparation, will have the same velocity, same speed in the space. All right. In a medium other than air or vacuum, the uh, the velocity of electromagnetic wave is given by E is equal to 1 by root of mu epsilon. It is mu epsilon. Mu is equal to mu 0 mu r. This is equal to 1 by root of what? Mu 0 mu r. This is epsilon means epsilon 0 epsilon r. This also we can write, right? Because mu is in a medium other than air or vacuum. In space or air or vacuum, the equation for speed is by mu 0 epsilon 0. Other than air or vacuum, the speed is given by v is equal to 1 by mu epsilon. Mu is equal to mu 0 mu r. Epsilon is equal to epsilon 0 epsilon r, right? This is equal to, this is 1 by root of mu 0 epsilon 0 into 1 by root of mu r epsilon r. This is equal to C only. Therefore, this can be written as equal to C divided by root of mu r epsilon r. So this is the relation. This value is constant. That is always constant to keep in the mind, right? The value of speed of light in air or vacuum is equal to 3 into 10 raised to 8 meter per second. This value divided by mu r epsilon r. In a dielectric medium, the velocity of all electromagnetic wave is given by B is equal to C divided by mu r epsilon r. So these are the important conditions. Then a question arises, what is the plane electromagnetic wave? A plane electromagnetic wave is the one which travels in the same direction, only one direction it travels. Only one direction it travels. Am I correct? Okay. And the value of electric field and the magnetic field intensity at any instant is depending on the space and the time. The space and the time, right? It does not depend on the coordinates x, y, or z. Suppose in this case, our electric field is in the z direction and the magnetic field is in the y coordinate. Electric field is in the x along the x coordinate, z coordinate it is vibrating, and the magnetic field is vibrating along the z axis. Am I correct? Okay. So this is what is called plane electromagnetic wave. What's a plane electromagnetic wave? When a question asked, we will speak that. Plane electromagnetic wave is the one that travels in only one direction. The instantaneous value means at any instant value of electric field E capital E and magnetic field capital B depends only on the space and time in which direction it is traveling. When the electric field is in the Z direction and the magnetic field is in the Y direction, then the electromagnetic wave is traveling along the X direction. That means space covered is along the X direction, right? The value of instantaneous value of electric field capital E and magnetic field capital B does not depend on the coordinates in which it is vibrating, but depends only on the space it covered in the direction the electromagnet is traveling. Electromagnet travels in the x direction only. So space and time. Space is x and it is time is t. So the instantaneous value of electric field and magnetic field can be given by the relation E is equal to E0 cos. I told you the variation, sinusoidal variation can be either represent terms of a sine ratio or can represent terms of a cosine ratio. E is equal to E0 cos omega, sorry, kx, kx minus omega t. Kx minus omega t. So electric field can be represented in terms of that. So electric field depends on x and t. K and omega are constants, right? Okay. Yeah, x, k is a constant. X and t, that means instantaneous. E0 is also a constant, right? E0 means maximum value of variation. Uh, the electric field is peak value of electric. It is not EMF, it is electric field, right? So instantaneous value at any instant, what is the value of electric field depends on space and time. The equation of a plane wave, the variation of electric field is separately given by E is equal to E0 cos kx minus omega t. And B is equal to B0. B is equal to B0 cos again kx minus omega t. The values, instantaneous values, electric and magnetic field depends only on space and time. Space is x because along the x direction only the wave is traveling. The space covered is only in the x direction. And when time increases, the space covered also increases. Any instant, what is the value of electric field and magnetic field asked? That can be calculated only by knowing how much distance the wave has moved along the x-axis and also how much time it has taken from the initial position from where the wave started. This is the situation, E and P. We can also, in this case, K can be proved as equal to 2 pi by lambda. So we have seen in the last year, right? Progressive wave, there is a 2 pi by lambda there. Here also it is appearing here, 2 pi by lambda. And omega is equal to 2 pi f. So that also everybody knows, right? Now, omega by k is equal to, one more relation we are getting. Omega by k is equal to 2 pi f divided by, again 2 pi by lambda. 2 pi by lambda. This is equal to lambda f. New lambda is equal to c only. This is one more relation we are getting for the velocity of electromagnetic waves, right? Omega by k. Omega by k is angular frequency divided by constant k. Any wave, there must be a constant k that is equal to 2 pi by lambda. Lambda is the wavelength of the wave, right? 2 pi is a constant. You will get omega by k also is equal to c. Two relations already we have seen for velocity of electromagnetic waves in the free space and also in the dielectric medium. That we already seen. Another relation for velocity of electromagnetic waves give omega by k is equal to c. That also proved, right? Also, we can say E by the ratio of electric field to magnetic field. Ratio of the electric field to magnetic field, that means E by B. E by B also equal to C only. Instantaneous value of electric field and also instantaneous value of magnetic field, the ratio of that at that particular instant, electric field and the magnetic field vector values are taken, the ratio is calculated, that also equals C only. And the ratio of the amplitudes, peak values is zero, also equal to C only. These are the relation for velocity of electromagnetic waves, right? Now it is characteristics of electromagnetic waves. Electromagnetic waves are produced by oscillating charges. When charges oscillate, vibrating charges can produce a time varying electric field. Everybody सबको पता है टाइम वेरिंग इलेक्ट्रिक फील्ड उसको किसको प्रोड्यूस करता है, टाइम वेरिंग मैग्नेटिक फील्ड को प्रोड्यूस होता है. दोनों एक साथ में प्रोड्यूस हो गया स्पेस में कहीं, तो क्या होता है, that interacting field will give rise to electromagnetic waves. Electromagnetic wave is a plane wave because it will travel in a certain particular direction only. Am I correct? And plane wave का condition भी मैं इस वीडियो में already बता चुका हूँ, right? These waves do not require any medium to travel. Second point, right? Electromagnetic waves are produced by oscillating charges. That is one point. Second point is what? These electromagnetic waves can travel through space even without a material medium. Through that also, these electromagnetic waves can travel. Everybody knows that. Sun से light आता है earth पे तो क्या है through space vacant space also light can travel. Light is a form of electromagnetic waves, right? They are of transverse nature. Transverse nature also I told you what is that? Electric field is in the Z direction. Magnetic field is in the Y direction. In that condition, wave travels in the X direction. That means the direction of propagation of wave is perpendicular to both electric field and the magnetic field. Am I correct? This is the condition. Their speed in the space is given by c is equal to 1 by root of mu 0 epsilon 0. Right? And also one more thing is that electric field and magnetic field are there. These electric field and magnetic field variations are always in the same phase. That means at the point of time when the electric field becomes maximum, magnetic field also becomes maximum. Both the fields are varying in the same space, in the same phase in the space. That is also another point. Speed in the medium already said that is 1 by root of mu into epsilon. The amplitude ratio already said. Amplitude ratio of electric field and magnetic field. What is that? E0 by O is equal to C. What is C? Velocity of electromagnetic radiations. Then average energy density of electric field and magnetic field are same. Right? Average energy density. Energy density, that energy density of the electric field we have studied in the first topic. That is half epsilon 0 E square. Okay. In the magnetic field, the average density of average energy density, that means energy stored in unit volume where magnetic field is varying, is given by half b square divided by mu 0. Sometimes b0 square mu 0 also we will take. So in b0 square means that means we will take RMS values and we will derive it. For energy density, we will get energy density is equal to half B0 square divided by mu 0. Otherwise, in instantaneous value, when you write energy density in the varying magnetic field region is given by half B square by mu 0. Am I correct? They do not contain charges. Electromagnetic waves travel in a certain region. No charge is there. So these electromagnetic waves cannot be deflected either by electric field or by magnetic field. Without that means electric and magnetic field will not affect the direction of the propagation of the electromagnetic waves. Right? Intensity of EM wave is given by half epsilon 0 E square into C. What is the velocity? And intensity of EM wave is given by both the relations because electric field and magnetic field both are involving in electromagnetic waves. That is also given by half d0 square by mu 0 into C. What is this? Intensity of EM wave is given by I is equal to half epsilon 0 E square into C. That is same as equal to what? Half B0 square divided by mu 0 into C. This is intensity. Everything you will get in the notes also, right? And go on seeing this video again and again. One more thing is that light itself is electromagnetic waves, right? Visible radiation is the best example of electromagnetic waves, right? Yeah, one thing you have to understand is that the optical effect of light is only due to electric field variations. Optical effect is only due to electric field variation only, right? Magnetic field variation is just transportation. transportation. It helps in transportation of the energy from point to another. The effect, what is called optical effect of the electromagnetic radiation called light radiation is only because of what is called variation of electric field, right? This much only I taught it today. Tomorrow I will bring with the electromagnetic spectrum and all the electromagnetic radiations. We will study in detail how they are produced and also what is the various uses of electromagnetic radiation. 7 electromagnetic radiations we'll discuss on the other day, and the lesson also will be finished. As it is short lesson, I thought this also can be finished very soon. That will be very good for you. You will go on reading your reference book and also collect more and more ideas accordingly as this year's syllabus. Right? Okay. We will see you again tomorrow. Thank you very much. Right? Goodbye.